Hi, everybody. Once again, your friend Dr. Salim is here with you guys. Today, it's a simple calculation. I really want to show you guys something, the mechanism of why when we increase our depth, why our frame rate is coming to be decreased. What is the relationship between the depth and the frame rate? And what is the relationship between the number of focuses and frame rate? So it just came to my mind, maybe some doctors, they really want to sit for their exam, like exam of ARDMS, or maybe somebody really want to sit for their knowledge, or maybe they are trainers. So be with me. Let me try my best to explain it, how that works. We all know what is a frame rate. We all understand this portion, that the frame rate is the number of pictures per second. That is the frame rate. Now, when we increase the depth, we have more depth to our picture, so our frame rate drop. It means when we have more depth, instead of 2 centimeter, for example, if we increase it to the 5 centimeter depth, in 2 centimeter depth, you may have, for example, we can say like 40 images per second. But if you increase your depth to the 5 centimeter, now maybe you will have something like 15, like 18. I'm just giving you example. It will decrease the frame rate. That's one thing. Secondly, for example, when we have focuses, the number of focuses, when we increase the number of focuses in a picture, then we understand our frame rate also drop. Why and what is the mechanism on this one? Let me try my best to tell you how that works. So let me share the whiteboard, and that will help actually. Let me share the whiteboard. Okay, so here it is. Let's see. We have a formula. The formula is simple and easy. This is a formula which is given to the machine. It's programmed to the machine, and the machine or the scanner will calculate it because of this formula. And the formula is, we have frame rate, if R is equal to 77,000 centimeter per second. And then below the denominator, we have the penetration. I'll just write penetration in a centimeter. So this is a penetration with centimeter, times we have lane per frame. So we have LP, we have LPF, lanes per frame, we can say. And also times we have N. N is actually the number of pulses per scan line. Now, for example, when we increase the focuses, the number of focuses in a picture, so actually you are increasing the number of pulses per scan line. Like, for example, when you have one focus and a 2D imaging, so you have only one pulse per scan line is coming and bring you the information. But when we increase the number of pulses, so actually you are increasing the focuses, more focus you put for your picture, because you make your lateral resolution better too. So that will make the beam more tighter, right? Like make it narrow, the diameter of it. So those are the number of focuses per scan line. Now that's why if we look below the denominator, anything below the denominator, we all understand this portion. Like all of these things, if we increase the penetration, it has indirect relationship to the frame rate, indirect relationship. Now, if we look lane per frame, if we increase lane per frame also, that will also have indirect relationship to the frame rate. It will decrease it. If we increase the numbers of pulses per scan line, it will also decrease the frame rate. So again, it is an indirect relationship. So we can see here, all these components are below the baseline. So just in case if somebody had that question, why the frame rate is decreasing, this is a formula which is programmed to the scanner, to the machine, and that's how they calculate. They give you the frame rates. Like, for example, lane per frames. For example, lane per frames, we can say if you are scanning with a 2D image, just simple 2D, two-dimensional imaging, you do grayscale. Your frame rate is pretended. It's a 50 pictures per scan or 50 hertz, we can say, correct? Now, if you turn on your color gain, color Doppler, not color gain, color Doppler. If you just turn on or activate color Doppler, so you are taking more lane per frame. And this way, we know that lane per frame is below the denominator. If we increase those lanes per frame, of course, frame rate will drop. So this was something just in case if somebody really want to know why our frame rate is decreasing while I just put another mode, like if we turn on another action on the machine, for example, if you give more work to the machine, more load to the machine, and why the machine is giving me less frames, less pictures per second. So this is one of the formula. I know maybe it's really good for those people, like at the beginning I said, who want to sit for the ARDMS or CCI or any national or international exams, just to clear the concept for them. Or maybe those doctors, healthcare providers who they are trainers, so they want to explain to their students too. And please, if you think these are really beneficial informations, please share it with your friends, other doctors, healthcare providers who are in this field, ultrasound field, if it's vascular, Doppler, or if it's echo, any part of the ultrasound they are. Share it with them, and also please don't forget to tell them subscribe this channel too. Thanks a lot, and see you for the upcoming videos. Thanks a lot. Have a nice day.